Kia ora koutou. I'm going to shout out because I tried using this morning and yeah, didn't sound too nice. So my name is Nasser Jackaman. Welcome to the software engineering presentation. So I'm the software engineering program director. I've only very recently taken over this role. However, I've been involved with software engineering in this department since 2002. That's probably the age that most of you most were born, right? Who's born in 2002? I think a fair chunk. I was just thinking about it this morning, 18 years ago, probably a lot of 18-year-olds here. So you'll be pleased to know that when I joined here in 2002, this was the very first lecture room that I went to, and coming from a small high school, that was pretty daunting. I remember it used to feel a lot bigger, but that's probably, that's the feeling that you get when you're straight out of high school. You'll be pleased to know that also it did not take me 18 years to finish my software engineering degree. It did take me the usual 4 years, so that was good. I studied hard, I got there in the end. I did hang around to do my postgrad study here in software engineering. I hung around a little bit more to dabble in a bit more research. And here I am, I've been lecturing for 8 years as a software engineering lecturer. I just want to set the scene with this quote from a respected software engineer. I'm not trying to be poetic, I'm definitely not a very poetic person, but I feel it is a nice quote. It goes like this: software is the invisible writing that whispers the stories of possibility to our hardware. It is these stories that will be told by and that will define the lives of future generations. What I like about this quote is that second half, even though the first half was quite beautiful, but actually that second half, when we talk about software, we're almost always talking about the impact that it has on our lives and just how it helps us get connected and be connected with other people. And we don't have to look far. That opening slide that you'll see around in all the presentations, university telling you connect with us using these software systems, we just can't get away from it. In this presentation, I'll obviously talk a little bit what is software engineering, what do software engineers do, show a couple of examples of sizable software projects out there. How does what we teach here prepare students in order to go and take on these big software projects? What are the career prospects? What does industry want from software engineers? And how does software engineering as a degree differ from a lot of other related computing degrees that you'll see around? This is the formal definition according to the IEEE professional body defining what is software engineering. Don't freak out, I'm not going to read it. Freaks me out. So I'm not going to read it just yet. We'll come back to this very soon. But this is an accurate definition of software engineering. I'm going to try a different approach. I'm going to say a software engineer, or an engineer in general, is a problem solver. That's all that it is, really. Now, that means software engineering is about solving problems by systematically applying computer science. So these are all three very important keywords. And you'll find it quite interesting. I use the word computer science because the question that a lot of you will be thinking, what's the difference between computer science and software engineering? Just like any engineering discipline where you apply science, and software engineering is no different. We're applying the science of computing to solve problems that are software based. And sure, when we think about software engineering or computer science, we're always thinking about coding, sitting in the corner in front of a computer, all locked up with just maybe a light bulb and typing away like a mad genius. That's known as coding, and that's probably what it was when coding first came in. You had to be some sort of freak to write code, but it's a very different story now. Writing code is just one tiny piece of software engineering. Once you've written that code, you've got to test it, you've got to integrate it with other pieces of software, but you can't touch your keyboard in order to write code, unless you've actually designed something. You've designed the solution, but you can't design the solution until you know what is the problem that you're trying to solve. So requirements gathering, going out, communicating with your clients and customers, and understanding what is it they're trying to solve. And trust me, clients will come to you and say, I want you to develop an app, or I want you to develop some software solution for me. And then you ask them, oh, what do you want? You know, what do you want? And they'll say, I don't know. So they don't know what it is the problem that they're trying to solve. So trying to flesh this out of them is part of the process. So it's about that systematic aspect is about the process of going through this entire journey, and you see this onion sort of layered approach to it, and coding is just that final part. So I'm a little bit more comfortable now to come back to this, but don't worry, we'll break it down. So software engineering, that keyword, application, we're applying a systematic, disciplined, and quantifiable approach. So that quantifiable, going from something so vague as a problem definition, and eventually ending up to, here is the software product, going from words to zeros and ones, there needs to be a quantifiable approach to do that. And what is that thing we're doing? It's not just about writing code, but it's the development, operation, and maintenance of software. Any software system that gets delivered, especially as it gets bigger and bigger and bigger and more people start using it, it's not going to be delivered, handed over, thank you very much for the paycheck, see you later. You're going to continuously evolve it. Other people that did not touch that software need to come on board and add more to it, and add more features that were not perceived when it was first developed. So it's about that approach, that holistic development process. There are plenty of applications out there. I'm not going to dig into these any specifically. You can appreciate that these are massive software systems. Booking a flight on an airline system, and it needs to be integrated with so many other pieces of software. I'm going to just touch on games. Who likes to play games on their mobile device? Me too. I'm guilty of that as well, so don't feel too ashamed. Mobile games, just playing games, building games on mobile devices. I'm not talking about all mobile apps, and I'm not talking about all games, PC games, just games for mobile devices. That is a $100 billion global industry. So that's a pretty massive, there's some pretty serious cash out there, and that's just for something as essential as mobile games. I'll go through a couple more examples. So TradeMe, this is something close to us all as well, where chances are all users of TradeMe, with 4 million accounts out there. I'm sure, again, we've got users here. But at any one point in time, we can easily have 100,000 people connected to TradeMe, searching, uploading photos, doing whatever it is that we do on TradeMe. And we expect, no matter what we're doing, for it to work in literally a couple of seconds. Otherwise, we get frustrated and we're probably not going to use that software. So we're talking about large amounts of users using the software, large amounts of data, large amounts of functionality, things happening at the same time. So the hardware needs to be scalable to handle all this high usage. We've got users doing all the various sorts of searching, but they want results that are actually good. You search for something, you get what you had in mind. So there's a bit of artificial intelligence there. But that software and how it became and how it got there, it was developed using big teams. And not everyone that develops these software systems are engineers or software developers. You need to work with a lot of multidisciplinary people, go and talk with customers and clients and try and figure out what it is that will make the software a masterpiece. So in our program, we teach a lot of technical content. And those are the top sort of ones that are relevant to this example. But these are the things that are quite different from other degrees. So in engineering, you're dealing with clients, people that are not engineers, that are not scientists, and you need that communication and that teamwork, those soft skills that will make the team gel together and be productive. Another example is this square kilometre array project. So it's still in the pre-construction phase. They're going to be building all these antennas, about 100,000 antennas going to be spread across mostly Western Australia in a square kilometre, hence the name. You can imagine they're going to be collecting a lot of data, a lot of data, a lot of data. Imagine all the data on the internet right now that is being transferred across, like globally. Double that. That's how much this system, this software system alone will be needing to process. That's a lot of data to crunch through. And obviously we're going to need the hardware to support this, but that hardware is useless if we don't have the software to actually make it come to life. So there's going to be a lot of high performance parallel computing from the software side involved with this. In general, software systems, we're talking about big software applications. We don't usually talk about a mobile app that will be a game that you can develop in a weekend for fun. We're talking about systems that will be integrated with a lot of other systems and that just needs to work and do its business. So even something as simple as ethics, how's that important to software? Well, to be a professional engineer, you need to be professional, so that's that professionalism. How do you go to clients, talk to customers, and ethics in terms of intellectual property. That's really important when it comes to software. Ethics in terms of privacy, again, very important around this software, these software topics. Whatever you develop needs to be reliable, so there's a lot of challenges, and it's a lot more than just writing code. Of course, the market, you've probably done a bit of research yourself, and it looks pretty promising. And this is the Careers New Zealand website, and it says, careers of getting a job as a software developer are good due to a shortage of workers. Promising. In terms of future prospects, is it looking equally as good? So the MB Occupation Outlook website says, continuing growth in job vacancies, and the demand is expected to continue increasing in this fast-paced industry. Fantastic. That sounds very promising. However, this shortage, it's not just about quantity, the number of software developers out there. It's about quality. So this report is talking that the shortage is one of quality, where applicants that are going to these applications for these jobs, they're lacking a formal and a deep understanding of software engineering. And the 5 most common things that they complain about when they're trying to hire new employees: a lack of formal engineering education, lack of experience, lack of soft skills, lack of technical skills, and for people that come and they have all those top things, they're demanding a lot of salary, okay, and fair enough. So it becomes like a premium if you've got all those things. I'm going to go through all of these one by one. In terms of technical skills, I showed a little bit what we teach in terms of the topics, so I'm not going to dwell any more on that. But in terms of lack of formal engineering education, first and foremost, software engineering here is part of the engineering degree, which means it is by being a degree that is accredited by a professional body, which is Engineering New Zealand, formerly IPENS, Institute of Professional Engineering New Zealand. We need to conform to international standards. So we are benchmarked against the Washington Accord. And the Washington Accord says by graduating from these degrees, you can call yourself a professional engineer. That means you can go out and use that title and do what engineers do. As an engineering degree, and because of that accreditation process, we have a very rigid and structured degree. In your first year, as you're aware, all the courses that you do are common across all engineering. Some of them are to broaden your understanding of different engineering disciplines. But some of these courses are to train you to know what it is to be an engineer. So teaching that professional side of engineering. In your second year of engineering, again, no electives, all software engineering courses. There'll be a couple of common core engineering courses, again, around professional development. Third year, again, 3/4 are core courses. In the fourth year, final year, it eventually opens up that you can take courses, not only software engineering, but computer systems engineering, but also electives from computer science if you want as well. But we also have core engineering courses in the final year as well. Lack of experience, nothing more frustrating. You've spent so many years studying and then you go out and get your first job. While you're trying to get your first job and they're saying, sorry, you've got no experience. In order to graduate from engineering, you have to complete 800 hours of practical work. That's typically done during the summer break, and it has to be related to the specialization you're studying. So usually students at the end of their second and third year will go out, look for a software company, and do an internship with them. That also has to be paid work, so you can't work with some folks that will, volunteering. And I think that's a good thing, because by that time, you will have the technical skills in order to do these software developments, and there's, you can do voluntary work if you want, but don't let companies use you. So that helps in order that, by the time you graduate, you've got a little bit of experience, you've worked at 2 different companies around software development, but also for a lot of our students, they'll usually keep the foot in the door of that company, and then that will be their first job after they graduate. But some will just completely go and look for something else as well. Lack of soft skills, and this is where engineering comes into it, that professional development, the ethics, and all of these core engineering topics to make you a professional engineer. That's where it's covered. Teamwork, we have lots of projects we're doing in pairs, groups of 6 easily, and in the final year we've got massive projects with 20 interdisciplinary, all these different specializations working on a common engineering project, and so collaboration, cooperation, all coming into this. And communication, both written as well as oral, these are things that we drill into our students and let them know, as an engineer, it's not about your technical skills. It's not what matters the most. If at the end of that, you've got all those things and you start demanding more from employers, I think that's a good thing. So it's a challenge for employers, but not a challenge for you. So, but jokes aside, basically, people with all these skills, it is a premium, and companies are willing to pay that little extra for someone that they can put in front of clients, that has the soft skills, that they can go out and communicate with people that are not engineers or scientists, and as opposed to just lock them up and do coding without anyone seeing them. There are a few degrees that are sort of, that will crop up in terms of how's it comparing to software engineering. The closest one is computer science and computer systems engineering. Mechatronics and engineering science, sure there's computing common in there, but they're not as closely related. Computer science, as a science, it's more about discovery. And there's a lot of flexibility in computer science, so you can basically go and do courses because they purely interest you. These subjects, just you personally feel really motivated and inspired about them. Whereas in engineering, you have to take these core courses, so it's a very rigid structure. So that's where the difference in the curriculum philosophy is, because we're not developing software developers, we're developing you as an engineer. But sure, you still have to learn the computer science aspects as part of that process in order to call yourself a software engineer. So it's discovery versus application. It's like saying, what's the difference between physics and mechanical engineering? Mechanical engineers, they still need to understand the physics. computer systems engineering. So there's the engineering aspect, but in computer systems engineering, that ratio of hardware to software, it's heavier towards the hardware side of things. So there's a lot more hardware involved there, but not so much that there's not enough software. In fact, because this is something that we teach in our department as well, by the end of the 4th year, we open up computer systems and software engineering quite a bit, that we have computer systems engineering students taking software engineering electives, and software engineering students taking computer systems engineering electives as well. So they do sort of come back and meet again in the end. As I mentioned before, our department has the computer systems engineering degree, software engineering degree, and electrical and electronic engineering. Now, the software engineering is co-taught by lecturers both from computer science and engineering. So you've got the two faculties working together in this program. And engineering is teaching not only software engineering in the core courses in the 2nd, 3rd, and 4th year, but you've got general engineers that are teaching those non-computing general courses, like mechanics and so on in the 1st year that is common to all engineers. Software engineering students have this awesome reputation of being a very close-knit group, and it's really driven by the students themselves, especially Software Engineering Students Association. And this togetherness is not only within the year, within each cohort, but also 2nd and 3rd year and 4th year, they do a lot of activities together as well, which is awesome to see. If 4 years were not enough and you want to hang around and do more, there's research opportunities as well. So you can go do masters or PhD in a software engineering topic. Oh, sorry, that's my timer. I don't realize it would actually go off. Oh, dismiss. I don't know how to use software. And then, of course, there's all these different research groups that will have various focuses on software engineering. That was meant to be my last slide. They gave this general slide, put it at the end when you finish your talk. I just wanted to raise that point of, again, software, defining how we interact and defining society these days. But I wanted to actually end on this slide, which is an open invitation for you to come to our Part 4 exhibition day. This is where our final year students will be able to show off their projects that they've been working on all year. We have software engineering projects, computer systems engineering projects, and electrical and electronic engineering projects. And that might help you, especially if you're trying to juggle between computer systems engineering and software engineering. Go up to a group and say, hey, so is this more software or is this computer systems? And don't be fooled. Sometimes you'll go up to a group of students doing a very software project, and then you ask them that question, and they'll say, oh, we're actually computer systems students doing a software engineering project. And other way works as well. You go up to some students, they'll show a robot or something, and then you ask them, oh, so you must be computer systems students. And they're like, actually, no, we're software engineering students. So they do come back at the end, and so you can learn a little bit about that. You've probably seen our lovely new building around the corner. So that's going to be open and ready for our students next year as well. So they'll be your new home. Cool. Thank you for your time. Feel free to ask any questions. I'll hang around.